Now we're on to section B. Let me put this down here to organize a little bit. Oh, I wonder where, oh, here it is. Okay, so my printer literally ran out of ink, like, I don't know if you can see, like right at the bottom of one sheet of response paper. So I'm going to use as much of this response paper as I can, and then I will be using notebook paper for the other section B problem. Yes. Okay, here we go. So this is paper 1, section B, number 1. Okay, so it says the displacement of an object from a fixed point O is given by S of t equals t minus sine of 2t for the domain 0 to pi. So part A says find the expression for the object's velocity in terms of t. So we're given S, which is position, and we're looking for v, which is velocity. And so all we have to do is take the derivative. So for part A, we know that v of t is equal to s prime of t. And so when we take the derivative of that s function, we should get 1 minus 2 cosine of 2t. Okay, we used the chain rule there. So we took the derivative of sine, which gave us cosine of 2t, and the derivative of 2t is 2. We stick that out front. Okay, so that should be your v of t. And for this part, it was 3 marks. So I'm giving you 1 mark for the 1 mark for the 2, and 1 mark for the cosine of 2t. Yep, that's that. All right, so part B says in the interval, in this interval, there are only 2 values of t for which the object is at rest. One of the values is t equals pi over 6. Find the other value. So we know that at rest means that v of t is equal to 0. Okay, and so sorry, thinking about random things. So we want to set that function v that we got in part A equal to 0. So 0 equals 1 minus 2 cosine of 2t. This will be nice. So we subtract 1 from both sides. We get 1 equals negative 1 equals negative 2 cosine of 2t. Divide by negative 2. And we get 1/2 is equal to cosine of 2t. Okay. Oh, I wanted to hide this thing so it wasn't in the way. And so now we ask ourselves, what values of cosine give us 1/2? Okay, so we're asking the question, cosine of what equals 1/2? We know that one of these is going to be pi over 6. Pi over 3 actually, and then we would need pi over 3 to be equal to 2t, solve for t to get pi over 6. So we draw out our little like unit circle guy. We see, so cosine is the x value and it needs to be positive, so it either has to be in the first or fourth quadrant. So it can be pi over 3, which is here, or it can be down here, which is 5 pi over 3. So hopefully you guys remembered your unit circle. So these are our 2 options. And so we would say that we know that cosine, I'm like using way more room than I should for the amount of response paper that I have available to me at the moment. So we know that cosine of pi over 3 is equal to 1/2, and we know that cosine of 5 pi over 3 is equal to 1/2. And so we would take each of those, we would take each of those values, pi over 3 and 5 pi over 3, and we set them equal to the 2t, because that's what's on the inside of cosine in reality. So we would have that 2t is equal to pi over 3. divide by 2 on both sides, and we get that t is equal to pi over 6. That was one of the values given. This tells us that we went in the right direction. We did the correct thing. And then we would do the same thing with the other value, 2t equals 5 pi over 3. Same deal, divide by 2 on both sides, and we would get that t is equal to 5 pi over 6. Okay, so our two solutions are pi over 6 and 5 pi over 6. So maybe I should have done that in here. Oh well, pi over 6. This is our answer. Okay, so we would get 1 mark for the method of setting our function equal to 0, our velocity function equal to 0, plus 1 for actually solving that correctly. You would get plus 1 for doing this stuff right here. Actually, like it's like this right here. For setting up those equations to solve for t, and then plus 1 for your final answer. This is the method. So there were 4 marks, 1, 2, 3, 4, and you should be good to go. Okay. And then we're on to part C. Part C, it says determine the value, determine at which value of t the maximum displacement occurs. Show justification for your answer. So maximum displacement. So we need to think about what that means. So that means like the biggest displacement, right? So if I had a graph of the displacement, which is s of t, I would want a maximum value. Okay. And so let's see, in order to find that maximum value, I need to take the derivative of my position function, which happens to be v of t, which we have, and set it equal to 0, which we did. And then I need to test each of those points and see if either one is a maximum. So basically, A and B set us up to be able to do part C. We've done all of the work except for the test to see which one is a maximum value. So I have x, I have my s prime of t, this is also v of t. Okay, I need a value to the left of pi over 6. I need a value in between, and I need my 5 pi over 6. And then I need a value to the right of 5 pi over 6. Okay, so this is how my table should look. If you would really like to, and honestly, I would probably choose to do this, you could do the second derivative test, find acceleration basically, and then just sub in pi over 6 and 5 pi over 6 to each part. If you did do the second derivative test instead of the first derivative test, give yourself full points, don't question yourself, as long as you got the correct point value as your maximum. And remember, with the second derivative test, if you get a positive value, it was up like a cup, which means it's a minimum. If you get a negative value, it was down like a frown, which means that you have a maximum. So you're looking for your function to actually have that negative value, which is a little bit counterintuitive. But remember, up like a cup, down like a frown. Okay, so now we need to actually figure out these values. So some easy points would be, hold on. Some easy points to choose would be 0, to calculate v of 0, v of pi over 2. Let's see. V of 0 would be here. That's a value to the left. Pi over 2 is definitely going to be between those two values. And then to get past 5 pi over 6, you only actually have to go to pi. So if you were thinking like this and thinking about pi over 3 and 5 pi over 3 from up here, it's not quite exactly the same, because we actually have pi over 6, and then 5 pi over 6 is going to be up here because 5 over 6 is less than 1, or 1 pi, which is right here. Okay, so so the v of pi value is going to be here, pi over 2 is there, and then 0 is right here. Okay, so if I sub in 0 for my v function, the cosine of 0 is 1, so I'm going to have 1 minus 2 cosine of 0. This is 1. That's 1 minus 2, which is just negative 1. So I have a negative value, so this is going to go down. V of pi over 2, it's just going to end up being cosine of pi. Cosine of pi is negative 1, so I'm going to have 1 plus 2, which is 3, which is a positive value. So we're going up here. We know both of these are 0. And then pi, so 1 minus 2 cosine of 2 times pi. Cosine of 2 pi is 1, and so I'm going to have 1 minus 2 times 1, which is negative 1, which is negative, so it's going to go back down. So this means that our maximum has to occur right here. So we have a max at t equals 5 pi over 6. And then determine at which value of t the maximum displacement occurs. Okay. You don't have to find anything more than this. You could have gone in and found what the maximum position was by calculating s of 5 pi over 6. You didn't have to do that. You could have used that, though, as a method to see which one is bigger. So you could have tested both 5 pi over 6 and pi over 6 in the s function, and then solve for each and tried to see which one of those was bigger to find the maximum. That would be fine. That would be a justification. But this or doing the second derivative test is probably what I would recommend, because if you think about it, you could have potentially 2 minimums. You would obviously have those. I feel like there's an inflection point I could come up with that would eliminate this issue. But hypothetically, maybe you had more than 2 stationary points. Like one of them could be a minimum and like be higher than the other one. So that's why I'd say to be careful, because we have 2 stationary points only. We kind of have to have one as a max and one as a min. So if you use that reasoning, that's totally fine for this problem. But keep in mind that if you have more than one stationary point, you're not guaranteed that just having a higher y value means it's a maximum. Okay, so just keep that in mind. Anyways, you would give yourself 2 points for the method that you used. You could either use first derivative test, you could use second derivative test, or you could use this for this problem only. And then let's see here. This was only 3 marks, I think. And then you get 1 point for your final answer. And that's that. So this part was 13. No, it was 10 points total. Okay. And that's it for paper 1, section B.